What's up, guys? I'm Kieran.
I'm Luke.
We're co-founders of NEMA Systems, and today we are going to have a potentially controversial, hopefully not too controversial, conversation around agents and LLMs and artificial intelligence and systems engineering. Luke and I share a lot of similar views, but also have a lot of very different views on how AI and LLMs can be used in engineering, and so hopefully we'll get to the bottom of it today and figure out who's right and who's wrong.
Perfect.
Who are you?
Luke, previously at Waymo, currently founder and CEO of NEMA, working on figuring out ways to bring about more cool hardware in the world. I think throughout my life I felt there's a insufficient amount of hardware that's around me, and that involves anything that moves, flies, or is on the ocean.
What do you think of the product that we're in right now?
Very expensive, but incredible. It took, think about like, there's a couple thousand Waymos, and it took maybe, $10-15 billion to develop the program. Obviously, it will scale and amortize, but think about like how much that's per vehicle. And this ride costs about 150 bucks.
Yep.
But how much value you're getting amortized over this.
It is quite incredible to see how far these things have come over the last 5 years. I remember when I was at Motional working on like just something as simple as a lane change and how terrifying that was to execute. And now, on this ride alone, we'll probably do 10-15 lane changes.
So we'll just
going up to San Francisco, and I won't even notice it.
Yep. Freeways.
It is quite incredible. What brought you to working on systems engineering tools or modern tools? What is the difference or the difficulty with existing tools in the world right now for engineering?
It's kind of two things, right? So number one, you've worked on engineering projects. You quickly realize that a lot of the time you're not limited by kind of like some first principle fundamental technology. A lot of the time you're bottlenecked by actually knowing what you want to build and how do you figure out how to actually disposition that work throughout the company, especially if you have hundreds or thousands or tens of thousands of people. And then kind of answer the questions like, how do I know I'm done? How do I know it's good enough? How do I know I'm ready to ship? Especially in the world we're in a car right now, it's kind of safety critical. I mean, we're going 60 miles per hour. It's physically possible for us to die right now, and that's very scary. And having that confidence in an autonomous system, it's a new idea, but something I spend a lot of time thinking about, and have been frustrated by sort of like the state of the art in terms of answering that question. That's one. And then the other one is obviously we're in the middle of probably the greatest technology shift that's happened maybe ever. I think we got to live through, when we were kids, we got to live through mobile and then the cloud as big technology shifts for startups that actually allowed you to do new things. And we see apps like Uber and Airbnb kind of sprung out of that. That hasn't happened for a while now, and now we're in the middle of this where LLMs kind of provide a fundamentally new capability that's going to change how things are done in really every industry. We obviously see it in coding already. We see kind of the beginnings of it in legal, some of it in things like accounting and investment banking. But I really think it hasn't really hit engineering yet, proper engineering. These companies building complex products, cars, airplanes, boats, it still takes a ton of time. It's not being accelerated just yet.
But so we were able to build rockets 50 years ago. We were able to build this Waymo. What is missing? I guess how was it done? How was it done at Waymo? Why don't we just keep propagating that into the future?
I think if your solution space includes spending a ton of money on it and just kind of just being dead set on making it happen, because that's both true in the case of a moon rocket and in case of a Waymo, that's totally valid and it'll work. And for really huge problems like this one, where the addressable market's in trillions, it actually makes sense. But when you start thinking about more narrow problems, like a sweeping robot, and a robot that picks up leaves, all sorts of defense products, it actually stops being economical to do it the old way, because the amount of rigor you have to put in the process and the amount of people you have to hire, the contracts you have to hire to reach that level of rigor to kind of convince yourself and society that this is good enough to actually ship, especially for an autonomous system, it's just not economical, which means it's not going to happen. And if there is a way, if there's a small chance that we can bring down that cost, so that a team that's much more agile, maybe a team of 100 people, maybe a team of 500 people, can reach that level of rigor very close to it. Mm-hmm. Suddenly that unlocks like a whole new category of products that haven't been possible before. Kind of like a Cambrian explosion of things in robotics and autonomy in defense. Just as ML and AI are starting to work, and that stuff's being a bottleneck. The systems are smart, but then teams realize it's like, okay, so we've kind of advanced from prototype to like a working-ish product, mm-hmm. but now the job to be done is going from like a thing that works N of 1 to something that reliably works at scale and it can be sold commercially. And a lot of the teams at that point realizes like actually that's like 90% of the work, and that's where the hard bits are.
But I think, and one of the things I agree with you on, and then we'll get into the stuff that I don't agree with you on, is the tools that exist nowadays. They worked for primarily hardware-based products. Like they worked really well. Like if you're building a suspension linkage,
right?
Like yeah,
that's perfect.
You can get away with the legacy tools that exist in the world right now. If you're building a product that has a complex dynamic between hardware and software components or hardware and software systems, it just doesn't work. And like on top of that, hardware engineers and software engineers are just like different, like just different beasts, right?
Yeah.
And I've never once heard a software engineer say, I enjoy working in your requirements management system. Like I want to go put in my requirements. I want to go put in my test cases.
It probably never happened. I think maybe the history of the world potentially never happened.
I think it is fundamentally possible for a software engineer to say that.
I think some German OEMs.
maybe a German OEM. Okay. How do you think we can get to a point where agents, LLMs, or the models that exist in the world right now can actually meaningfully start to contribute to like engineering designs? Like what major advancements do we need to be able to do that?
I mean, again, going back to like why do software engineers have that reaction? I think it's perfectly natural where these guys for the last 10-15 years have been sort of like the fastest at these companies. They can if you could code, you had this tremendous leverage and you can kind of move fast and you didn't have to talk to anybody. That is now even more like accelerated even more with LLMs and coding agents. And suddenly you come in and say, actually, hold on, I'm going to put a speed bump here, and just kind of like step out of your workflow and just do the thing, do the process that I'm asking you to, often without fully explaining like why that even matters. So like there is, I think generally two breeds of companies. There's one breed that sort of like follows compliance for compliance sake, mm-hmm. and and then there's another one which actually cares about how do we think about the process of systems engineering, the process of building a thing, of defining a thing, so that it helps us build it faster, so that it helps us move more efficiently. And a lot of the customers we're working with are like that, where they really care about like the fundamental acceleration point. And when you put these speed bumps in front of them, they're just like, why are you doing this? So that's one item, which is like the traditional process is just completely broken for moving quickly. But then kind of like the other alternative is, okay, we'll just let's just use Cloud Code. Mm-hmm. It's wonderful for software, kind of like run it in dangerously skip permissions, ask it to do
favorite.
Your requirements, do your test cases, do the FMEA, and just like it'll probably say it's great. Like your system looks great at the end. And then when you point out a mistake, it'll say, I'm so sorry, I missed that critical error.
My honest take.
Yes, I'm so sorry somebody died. So there's a couple things to bridge that gap. Number one is a lot of, really every single big lab out there right now is kind of like giving a lot of giving pitches around how they're going to like solve science and help bring about like a new age of prosperity. But really like the work they've done so far, while incredible, is just really confined to kind of like the coding domain and digital, and does not trivially translate to actually like seeing physical change like the car we're in right now. I think this is not bad will on their side. It's more like these people are relentless optimizers. They just love that stuff. They're just like here's a benchmark. I'm doing poorly on that benchmark. I'm going to do everything possible in terms of like gathering more data, improving my model, improving my RL to hill climb and just kind of like close that gap. As much as we obviously have amazing benchmarks for coding. Mm-hmm. There's some good ones for math, decent ones for professional work like investment banking, accounting, legal, but then nothing, really like absolutely nothing on hardware engineering, on building physical products, and also nothing on like building complex physical products, kind of like the systems engineering angle here. So no evals, which means like the models are not tremendous at just performing out of the box. And then second is like, as we're thinking about, let's assume the models are good, or you can actually make them good through a bunch of back-end work. You're still faced with this problem of like, you get a spreadsheet of 1,000 rows, and the model's like, here it is, I'm done. Review my work, and figuring out ways in which you can redesign the user experience around making that review as painless as possible. Now that it became the bottleneck to the entire process, is the next problem to solve.
And so how do you actually do that? Because I've experienced that myself. I work with Claude or I work with Codex or whatever it is for an extended period of time to do a DFME on a system.
Right.
And you do get that 1,000-line spreadsheet at the end and says, here it is, we're done. Like, please approve this. Which I guess gets into the question of like, how do you keep accountability on the human, or is the agent or the LLM or the system that you're using the one that's accountable for your safety right. design, or putting this Waymo on the road, or launching a rocket into space?
I think we're some ways away from one-shotting a rocket.
Okay.
I think there's some hype built around that.
Some people disagree with you on that, just to be clear.
There is this famous IBM line that the computer cannot be accountable for management decisions because there's no, it cannot face a downside. I mean, turning it off is not scary enough for Claude. So I think heads of safety will stay in place still for a while, especially that we don't even know, given the no benchmark thing, we don't even know how we're trending. It's like, what is the gap to close? At the same time, the work that their teams need to do is very often super spiky. So just like, like the eng team is kind of like doing their thing, they're prototyping, they're building, and then 2 weeks before final review, there's like, okay, like, can we just go through the requirements? and then suddenly you have to like review everything, just make sure that everything's connected up the way it's supposed to be for ASPICE or other standards. And that is just like kind of very uninspiring work. Mm-hmm. It kind of kills your soul to just like look at Cameo or one of the existing tools and just kind of like, here's a 1,000 lines that you have to review. So automating that part where you have a trusted agent whose work you can actually trivially review is the unlock that we're looking for.
And I think that leads to a more general problem of this like uninspiring work, is that a lot of the system engineering deliverables, outputs, whatever it is nowadays, are much more for like checking checkboxes rather than actually like providing value to the system or like providing value to the product. And systems engineering in general has gone away from this, like use your brain work, and has more become like an administrative workload on a lot of companies.
It's kind of like, did you go to engineering school to do that stuff? Yeah. And I think that very frequently the answer is no. At the same time, it's obvious that without doing that work, the systems will not ship. So it's super critical. It's just we've designed the human process to be computer-like. It's kind of like, here's the steps you follow. Here's your handbook. Here is like your FHA, your PHA, all these steps that you have to follow. But it's great because now if we can throw the agents in the loop and actually like get people offboarded of these tasks directly, but like supervising the higher level thing.
And so I think this leads into one of the areas that I disagree with you on, is that there's no, like, yes, agents are very good at, our processes are very good at, following, by definition, it's a process, you follow these 6 steps, and you suddenly, 60 steps, and you suddenly get a car out the other side. And so you can develop agents to be able to follow these processes and do these steps. Mm-hmm. I have never, that's very by the book, and I've never met an engineer that's by the book that I enjoy working with, or that has like significantly provided value to the programs that I've been working on. And I think that gets to this point of like, yes, agents are useful at going by the book and doing this work, but they're never the ones that actually make the 10x different, or they aren't the ones that make the 10x difference to the product. And I think that there's this major gap in using agents of like, how do you inject engineering creativity, engineering taste, or your company taste into the product that you're building.
Right.
And so I don't know how we overcome that gap, or how we get around that right now.
Step one, if you can actually if you actually like free up enough time for people to get a chance to think about this stuff, it's like, what is the 10x change I can make? Like, what is the, effectively working with like a really good LLM system, really good AI agents, like you're kind of the entropy generator. Like this is where these systems struggle with. Like they're often mode collapse. They often like give you the same answer kind of like every time, and then often the answer maybe is like not perfect. But then if you can guide it the appropriate way, you can really kind of go very far. So like the human then becomes like this sort of like entropy generator that if you kind of like draw parallels to like the coding work, when it sort of became crazy where so much more of your software engineering workflow is now automated, and you don't actually have to like define types and write things down or write any code down, but you're actually more busy. But at the same time, you kind of love it.
I'm a mechanical engineer by trade, and like I can ship stuff nowadays. So like yes, it's totally changed.
I think there's some people who hate it, but like there's just like people who knew what they want built, but just like couldn't sort of like get that traction of actually like sitting down and getting enough time to actually build it. Like they're just so much they're busier than ever. They're shipping more than ever, and they're also happier. And I think how do we bring about a similar change to systems where you're able to do work that might have taken many months or maybe multiple years, and kind of compress it, and suddenly you find all these bottlenecks throughout the company that you like, no longer we're not waiting for our DFMEA to finish to understand which tests to run, right? But suddenly I was like, okay, let's go. Like next up, it'll take a special type of company to really lean into it. I think back to your point, I don't think there's like anything super special about carbon-based intelligence. So as long as we're able to capture the context of everything that's going on in the company, as long as the models are actually trained the way they should be and they score well on evals that we care about, and we have ways for these systems to interact well with humans, then you realize suddenly you can move like 10x or 100x faster. So like things that you're going to be bottlenecked basically on physical activities, which oftentimes today is not true, right? Like you're kind of bottlenecked on like making decisions and figuring things out, and that should never happen.
God, I-280 is so much better than 101. No?
I think so.
So, we used to always come up to this bridge, actually. We used to test a lot on I-280, and the lines on this bridge used to not be well painted.
Not painted.
And so it was known that every time you pass this bridge on I-280, you're going to get swerves. Like without a doubt. You just always had to disengage coming up to it.
You're saying before the total displacement, like the integral displacement of the steering wheel over the course of this ride is maybe tens of degrees.
If that. Yeah.
But knowing which displacement to apply, it's a very hard problem.
We were running an executive demo, and we were thinking of going out one night and painting lines on that bridge.
Amazing.
Just to make sure that we didn't swerve going across it.
It's the most overfitted highway in America. It's a Robotaxi.
Nice Robotaxi.
Yeah, with a safety passenger, maybe. In California, it's a safety driver.
But there's something about the scale that just looks wrong, though. And it's amazing, like they've got the aerodynamics where the rear wheelbase, the rear track is thinner than the front track.
Glad they're testing on a freeway though. Not scared.
It's quite incredible.
You can fit 2 per lane. So like the maximum bandwidth of the freeway doubles.
So you're talking about review, the 1,000-line DFMEA. Your NEMA agent outputs this and says, ready to go, ready to ship your car. Just click approve. What are tools that you found or processes that you found have been useful to accelerate that review process so that you actually, at least you can reduce yourself as the bottleneck, or you're no longer as much of the bottleneck for that?
Yeah. I feel like there's been, I feel crazy for saying this, but I feel like there's been a huge disconnect between all the work that's happening on the ML side, which is kind of like the background I come from, in terms of optimizing for code bench and these benchmarks and sort of like professional work, where people have been basically asking these questions like how do we verify? And there's kind of like 3 levels that that have been like relatively like three sort of grades of verification that have been relatively successful and people have like just good results with. So number one, the one that's kind of like the most obvious and works the best is if you just have code or math, something that's kind of trivially verifiable. If your model comes up with an answer, it can run a compiler, it can run that code and actually get a warning, get an error, and iterate on it. So that lets you set up these long-running loops where you just kind of just give it like a high-level task, like here is like 200 tickets to implement, or here is like just kind of replicate that compiler, like that C compiler, and try it on this repository, and then just like do not stop until everything's done, and you can just kind of like enable that long-running work. So that's like gold standard and not applicable to something like systems because it's tricky to kind of trivially verify it. Number two is you have a simulator. So obviously, a simulator just will have like a sim to real gap. It's not perfect, but at least you have something to run it against. And some people have tried things with engineering this way, where just come up with a circuit board design, and then have a simulator execute it, and that's also like a decent proxy. And then there's all these fields that require very complex multi-step workflows. Like things like creating a valuation for a company and as an investment banker or private equity person, or running through like a complex tax scenario as an accountant, or reviewing previous casework as a lawyer and understanding how does that apply to your case, or running through complex discovery, kind of like picking up the right pieces. So workflows where you have to take hundreds if not thousands of steps to get to the final result, and at each of these steps you can make a sort of like basically a killer mistake where once you kind of diverge, it's very hard to come back, and it's non-trivial for you to assess how well you're progressing towards the goal, right? Because it can be it's just really hard to actually like roll out the entire evolution of the model, get to the final step, and then sort of say, oh, did we get to the right answer or not? So people have come up with these approaches of like judging by kind of decomposing the problem to have like LLM kind of like judge itself. And the trivial implementation of this is just like at every step just ask Claude or ask ChatGPT is like does this look correct? And what's the difficult answer is like
my honest take. I mean that's kind of the fox guarding the hen house, right? Like
yeah, so that doesn't really work. But then and people have found that this is already like that there's work done in these fields where people have found it, and then you have these approaches like for example like creating individual rubrics, which then allows you to guide the judge model in like a more fine-grained way to actually assess how is the answer doing against like a set of fairly deterministic criteria that you've developed before.
And I think that's the challenge though, is that with engineering, when you're doing systems engineering work, when you're developing a new car, when you're developing a new AV system, when you're developing a new rocket, it's so difficult to come up with that rubric. And like that's why we've got engineers that do it nowadays. And so I think this is one of the areas where I disagree with you on of trying to processify, or however you want to call it, how an engineer thinks and how an engineer designs a product is very, very difficult. And this makes it like, maybe not impossible, but fairly intractable with current models to be able to like do this review process or give these systems these rubrics to be able to do this.
Sure.
And so I don't know, like the ways that I've found have been really useful for this or very valuable for this is just to like treat it as you would a direct report on your team. As you're an engineering manager that's reviewing your direct reports work, like what is the process that you use to go about reviewing their work? You
just probe it.
You probe it.
Ask them hard questions.
Yeah, you have a couple things that need to be in the document or whatever the thing is, and so you probe on those specific things. You ask questions on like how did you come up to this specific solution, and you try to build some form of confidence that the path that the system took is right. Yeah. So how do you build, like I think my view on it is how do you build tools to enable that review process?
That's a UX layer.
Yeah, that UX layer, exactly. Right. As efficiently and as effectively as possible, so that maybe one day you're having one-on-one. The tools are you're having one-on-one meetings with your agent like you would your direct report,
or 20,
or you've got really good Slack integrations or whatever it is. But you need to replicate that relationship like an engineering manager would with their direct reports.
Like how do you get to the trust level where you're just like, okay, this is real. Yeah, I mean, there'll be a step where there's like a UX to bridge, and I think that's kind of our job to figure that out. And there's like some secrets to be discovered that haven't really been done in previous generations of this type of software, because it wasn't really a bottleneck at any time, right? It was always like you have to just kind of like grind things out and write everything down. It's not that it became a bottleneck, that becomes the thing to target. I would kind of throw it back at you and ask, like, what is... I agree that it'll take time to get there, and it'll take like future generations of models that are better, maybe some new approaches that we're not even thinking about right now. But I mean, the question I would ask is basically like, do we have a choice? Like the level of complexity that we're hitting right now with sort of humanity's greatest projects, the F-35s and the Waymos and our drones that we're building, it's so high. You kind of have to stack people on top of people, and then you end up with a team of 40,000 with 1,000 subcontractors, and nobody knows what's going on, and then you're just spending all your time managing.
Absolutely, I do think we have a choice, and I think the reason for that is because there's so many low-hanging fruits. Like there's so many people that are focused on like linking requirements to test cases. Like that is their job. Right. Is they just go through their current requirements management system, and their job is making sure that requirements have
full traceability.
Yeah, have full traceability. Yes. Which is the most meaningless, or not meaningless, the most like the most LLMable job that's possible. There's folks that are just like their focus is on like making sure requirements adhere to INCOSE standards.
Right.
Like you have like a full contractor, a full headcount that's just like it's purely dedicated to that. And I think that there's the ability to give those sorts of, and they're useful on the whole, like as you're...
Well, they're getting paid, right? So like the capitalism says.
People clearly value them.
I think they haven't studied engineering to do that work a lot of the times.
Right.
And then, yeah.
But I think that there's so many low-hanging fruits to go after for those sorts of roles, for those sorts of things, rather than doing spending all the time on figuring out how to one-shot a rocket. Sure, one day, yes, one-shotting a rocket is going to potentially be useful. Maybe we're going to need Opus 12.6 for that or something like that. But I think that, like, yes, we do have a choice right now, and that's to go after a lot of these very LLMable tasks. And
incrementally build that to the capacity.
Incrementally build that so that, right now, today, a team of 5 system engineers can act like 20. Tomorrow, maybe it's those 20 engineers can act like 200. And then finally, you never need more than 30 systems engineers on a team to deliver a Waymo like this.
Or you can like up the ceiling on the complexity. I think right now we sort of like are a hard limit on the complexity we're able to hit with human-based teams.
Yes, and if you live in that world where you want to develop the Dyson Sphere, which is great, that's awesome. I know there's companies that really have that as their goal, but I think that there's so many there's just so many more low-hanging fruits than you need to get to the Dyson Sphere.
It's possible that this might be like the bootloader step to get to the other part. Like, given that there's no eval sets and benchmarks today, there's kind of nothing to throw at a lab in terms of like RL or like evals to actually have them improve. But I'm starting to see that there's companies that will basically are starting to think in this feedback loops where like every time I'm getting an answer from an agent, from an LLM, I want to correct it, and I want that correction to actually sort of like be integrated into my knowledge base, into like my like the IP stack that I'm building up. And a lot of the time, if people kind of are just thrown in their own like Claude sessions, that context never really gets anywhere. It sort of like dies with that session. And sometimes people will create skills, but that still like lives on your individual computer. Cracking a way for to even for these simple tasks, to have these loops where like there's a proposal and then there's like an approve or reject step, or like an experienced engineer can provide feedback on like what's going well, what's going poorly. Like that's what I think it gets us to the kind of ultimate vision of kind of just executing that autonomous very, very long running session with maybe thousands of agents.
Regulatory stuff.
Why are we in the left lane? I kind of hate the left lane hogging.
Why? What's wrong with the left lane?
The left lane's for passing.
Versus going into the
the leftmost lane is for crime. Right. This lane's for passing.
Right.
And I don't know what the other two. I guess the right one's for merging.
Eleanor drives in the far right. So here's one. I'd love to get your take on this. Why do you think systems engineers and software engineers never get along? What drives that? What is the difference? What is the difference in their way of thinking?
At a place that I work, everybody would get along just fine.
That's not my experience.
I mean, it's, do you mean like beyond like the kind of throwing speed bumps in front of them?
Oh, yeah. I mean, that's one of the things I think.
I think that for whatever reason, like there's companies where system engineers will get relegated to be these sort of compliance and process enforcers because nobody else is there to do it, and the tools don't really will not really bump you themselves. So you need a guy that will ping you on Slack and say, "Hey Kieran, have you approved this requirement?" Mm-hmm. You've been a project manager. I think the job is quite similar in many respects.
It's an ugly job.
If you come back to the review cycle, the review is still a bottleneck for even if you have a human process, and if you a big part of the job is sort of you're the alignment guy. And also people come to you. You're also the bottleneck to answers to a lot of questions. So if somebody if a software engineer needs an answer to a question why am I working on this, or why does that matter, or what do I need to hit, they just kind of want an answer and just move on and start shipping. And if they need to schedule a meeting or wait for somebody to come talk to them, I think it just feels like the bottleneck in their flow. And if the system exists, then they can ask that question directly, and it's almost even if the systems engineer eventually reviews that answer, but as long as basically you get that answer right away, and you can actually improve on the quality of that answer over time, that feels very powerful. Otherwise, you have this thankless job of being a process enforcer, and at the end of the day, the CEO or CTO will ask the head of systems the question: are we safe enough? Is this good to ship? So they hold that responsibility, and that's why the burden is on them. But it's been if you look at the pitch of any legacy requirement software, they'll try to tell you that will bring your team together. Right. And you're it's a kumbaya. Everybody will sort of work on only the relevant things and on only super efficiently and never have any beefs. I think that vision has not been realized so far, and I don't see a way that doesn't involve a massive technology headwind to automate a lot of this stuff that resolves this. Otherwise, just making prettier tools that are sort of nicer to use and more colorful. I mean, it's incrementally better, but it's not gonna lead to you winning the market and shipping orders of magnitude faster than your competition.
I think if I can add on to that, there's also a world where, or a theory where, our products have continued to get more and more complex, but our processes have not adapted in any capacity. Meaning that we still require the same amount of documentation to prove something is safe, or our processes at least say that we still require that much sort of documentation.
I think more.
Or more, yeah, or more. And given that the complexity of the products have continued to scale, that amount of documentation has just gone through the roof. And as they scale, it's an n-squared problem of you just get more and more failure modes, you get more and more hazards that come up, and whatever it is, that it just becomes intractable, and you need to hire these teams of systems engineers to be able to satisfy this compliance. And I think software engineering inherently is a little bit more individualistic, blow down bureaucracy, blow down walls, just go. Mm-hmm. Whereas the process of system engineering is very, group mentality. How do you work? How do you keep the entire
How do you keep the system together, right?
Yeah,
that's the job.
And it's just a completely different mindset of working together.
Do you think we've hit is there a ceiling to how complex a product can be if there's
Well, we haven't built the Dyson sphere yet, so yes, I think that there's
is one shotting a Dyson sphere?
Yeah, I think it's a couple years out before. I think we'll need some technological waves before we can get to the Dyson sphere. But I think you've seen it. You can develop a small quadcopter drone with maybe 1 or 2 systems engineers max. And you start to develop more complex, less software-defined vehicles with, maybe 50 systems engineers or something like that. and then you hit a Waymo where you've got a 200 systems engineering team, where you're getting orders of magnitude more systems engineers without orders of magnitude more complexity in your product, and so you're finding some asymptote towards like how the types of products that you can deliver. And so maybe I don't know exactly where that line is for the complexity that you can ship, but I do think that there is some barrier or some ceiling towards how complex you can go. And without the ability to have some sort of assistance, whether that's an LLM or whether that's some agent that's working on your team, to be able to manage that complexity, which they're very good at, I do think that we're going to run into fundamental limits of how complex our products can be.
Yeah, the systems process, it's kind of interesting. Like if you go through JSA for defense companies, it's like we've developed these hundreds of pages long documents and processes, and really like it reminds me of model prompting. And people always have that analogy of like when we invented the steam engine. Like brains were just like steam engines, and there's like typewriters. It's like computers, and now it's like LLMs. Brains are just like LLMs. But like, if you indulge me, we've developed this process of basically prompting teams of systems integrators, of systems engineers, to sort of like elucidate failure modes and problems and hazards in the system by adding modifiers to your functions and sort of like asking particular types of questions, and then following like a fairly rigorous process to always know, I have a hazard that's not connected to a requirement, I have a requirement that's not connected to a test case. And that's, I think, that part of sort of like the frustrations people have with that process is because it's kind of like very, very mechanical. But if you start thinking about, agents and LLMs kind of doing parts of that work, you can ask higher level questions and sort of guide them through it, where really the thing you care about at the end of the day is that is my system safe, and like what are the trade-offs I can make along the way. It's like I think there's like a my dream and sort of push would be like there's a world where we can actually scale back on compliance if we do more of that. If we can more robustly answer the question around how safe something is, how do we know? Because like all the frameworks and all the kind of audit and layers people put around these products is so that we have sort of like a human level of assurance. It's like we've done our job, we've done our work, but that's because we're kind of fundamentally bottlenecked on like the economics of the problems. Like we cannot throw like infinite people at this to kind of like explore every single failure mode possible. So there was a world where we're starting to see it, and that's very encouraging. Like even for highly regulated industries, the regulator or the government, the acquirer, will actually make room for creating trade-offs if you're smart about this. If you come in and say, okay, actually it makes sense to run these things because it actually makes our product better, because we want to have 100% certainty, or we can actually pare down on the other items that have been there more like as more for like ceremonial reasons or for like historical reasons. It's like if you're able to run all these things kind of in parallel and sort of like basically like in a spiky way scale up your systems engineering workforce, I think there's a world where we can actually like scale back on like the level of oversight that these systems require, while maintaining or exceeding the safety level that we've been shipping with.
But in a world where a lot of products are moving towards like end-to-end networks, input images, output steering torques,
right?
You don't even have the reliance on systems engineering. The reliance on systems is far less important.
There's no function to annotate with requirement 17.
Yeah, it's a big black box of input images, output steering torques.
Right.
Is systems engineering still useful in those sorts of scenarios, or is system engineering still does it still provide value to those sorts of products?
Right. I think marrying these two worlds is such a fascinating problem. It's just like you have a lot of the time like this gets implemented in practice, and like people do that for LLM rollouts as well, but also in autonomy, where you have this machine learning model that sort of like is responsible for kind of like the creativity of the system and like creating like many solutions to a problem. Like right now, like we probably can stay in this lane or maybe change lanes or slow down, and kind of like thinking about all these possibilities at the same time, especially in situations that are ambiguous and there's like a construction happening and maybe there's like a construction worker waving. and at the same time putting that system in context of something that you can have guardrails over, and actually understands like, okay, I'm actually going to stay between the lanes unless I have a really good reason to sort of swerve out, or I'm just kind of like mostly follow the speed limit unless I have really good reason to do something else. These worlds have kind of like lived their separate lives, where the ML teams focus on their evals and make sure that they have good scores, and they'll climb their performance, and oftentimes they kind of cover the nominal cases. So like basically in case of a car, that'll be just like regular driving, kind of like sampling that through different environments, but still like kind of nominal set of scenarios.
Yep.
And then the challenge of actually shipping a system is that then you have like a whole array of like just oddball situations of just kind of like things that happen 1 in a million, 1 in 10 million miles for cars, but that's true for like basically every domain. And how do you get confidence that your system will still perform correctly? And that's often where sort of like the systems team is tasked with, like, guys, figure it out. And that involves like creating custom structured tests and really like thinking through the failure modes and like doing some formal analysis.
Yep.
And it feels like there's a huge opportunity to actually like bring these two worlds together, and that in some ways already happen in the world of like LLM rollouts, and that's how people think about like eval and guardrails and safety guardrails for LLMs. But like how do we bring that closer to physical reality, physical machines? My take would be like the role of a systems engineer kind of would start leaning more into a direction of like a product manager, where they're responsible for being this entropy generator, for kind of like thinking through the desired behaviors of a system and ways in which we can test that and measure it, and kind of being responsible for it. But like ideally operating at this higher level of abstraction of like being like based on their experience and their knowledge.
I don't have anything else that's useful to ask. That's the problem. I've depleted all of my knowledge.
All your frustrations with me.
Yes, all of
Ralph loops.
Yes, Ralph
Should we
loops
talk
and
about Ralph loops?
Gastown.
Gastown.
All right,
when are we going to see Gastown for systems engineering?
Yeah,
what's Gastown?
Sell me Gastown.
Sell me Gastown. Oh my god.
And don't make me infuriated while you're doing it.
It's this insane project where how you ask something to Claude, and it's a simple question, and then it gives you like 5,000 word essay, and you're just like, what?
Yep.
You scroll through it, you're like, do better.
Yep.
I think that's number one, and then number two is like there's two saddest moments when using a coding agent, coding hardness. It's like one is when your context gets compacted, and that's like brutal, and then second when it stops, when it's like stops working, and you're just like, I pay for the subscription, like just continue. So Gastown is an attempt to solve both of these, to keep you at the level of you inputting a like high level direction of like, here is the tickets I want done, here is the the process I want followed. It's like a to-do list, and then it's like a very involved process that has like very wonky names, but basically it'll kick off these jobs, kind of like continue working on them, continue iterating on them until it's done, and then it'll like summarize it in like a very brief way.
Yeah, I mean that's nice, great. Like I think so I didn't mean to rudely cut you off there, but maybe I did mean to rudely cut you off. Like, if I'm a system engineer, like my biggest problem in the world right now is that I have duplicate requirements all over my project. That like the asshole on the perception team put in the same requirement that I did, just worded it differently because he was mad at me. And I just want a system to be able to help me garden through my entire database.
And we're just like gassed out.
Like all, make sure all of my requirements have good traceability to my test cases, make sure that there's no duplicates through the system, make sure that it's all structured properly, make sure that it models, it's always up to date.
Yeah.
And I think that the value that, tooling companies like ourselves can provide to these sorts of people is being able to make sure that their systems engineering model of their product is always up to date, is always accurate, is always fully traced, and is always, can always act as the actual source of truth. And I think that, like, going back to the point of low-hanging fruit previously, I think that's truly the lowest hanging fruit of, if you can solve that problem, you can make so many systems engineers happy now with like the current technology that we have available to us now, rather than having to wait for 1,000 system engineers to work for Mercor and generate a bunch of data to be able to train all these foundational models to actually be able to do useful engineering. Because I really think that's just so far in the future. But
is it? How far in the future?
It's not tomorrow. Is maybe what it is.
That's your look ahead window.
I mean,
Just tomorrow.
That's what the look ahead window is right now. Things have changed so much in the last 6 months of product development using
This is
AI.
the time to maximize technical debt, procrastinate, and wait for Opus 4.9 to come out.
Yeah, I think that we can already close to 10x system engineer's ability today if we just use the tool, if we just apply the tools that we have in the right way. And I really think that's the quickest way to actually get a stranglehold on the market.
Yes, and I think I have a intuition bordering with certainty that we want to maximize token burn per customer for at least the next year. So the burning problem for me is like, yes, of course, like all those things are valuable today, and they're just immediately useful. But if we can crack a way of converting tokens into actual insight, and if that takes 12 hours of something running, if that takes 24 hours of something running, that is going to be such a huge unlock that it's worth sort of like 9 out of 10 attempts to fail. Mm-hmm. I think it's we are the team to crack this problem, because it's just so frustrating that nobody else is looking at it, and not looking at it from a lens of like applied AI scientists, of people who have like worked with ML systems, as like the balance to strike is sort of like, how do you convince and build trust with people today, and kind of like how do you give them value today while gunning for a 10x 100x solution? Because if you're able to convert it, every night burn $1,000 or $10,000 of tokens per customer, and give them one insight of like, oh, you've missed this, but like actual like real thing, not some trivial like your requirement's missing a comma, or your INCOSE guidelines are not there. It's like, what's gonna make them say, shit, oh, like that's actually a big gap, like we need to have a meeting about this right now.
But I think I would reframe it, the optimization function, drawing on something that you said. I would reframe it as, how do you maximize token burn and convert that to engineering trust in companies? And I think that's one of the biggest bottlenecks right now versus insights. Yes, your agent can produce a shit ton of insights,
but it's just like, here's 1,000 insights.
If no one gives no one trusts the output, it's even like, that smart engineer that the company that most people hate, like they don't get as far because like people hate them and don't trust them. But if you're for the engineer that's like really like is solid, but everyone appreciates their work and trusts their work. Mm-hmm. I think that's
just like
where
explainable and
very explainable, understandable, trustable.
Right.
I think that's where you can start to really get in bed with a lot of customers and get integrated into their daily routines and their daily work, and actually start to provide them a ton of value really, really quick.
What do you think about I think there's some companies that are really into that vision, and there's some that are just like, oh, hold your horses, slow down.
There were also companies that were really scared about the printing press back in the 1920s.
Okay, I was just like a trivial argument. Okay, yeah. So just like, boomers gonna boom.
You need to embrace it. You absolutely need to. But you can't shove it down someone's throat. I think that there's too many, like, engineers are just skeptical skeptical of things by nature, and shoving it down their throat.
We've seen people who told us that they'll never use an agent in May, June last year, and now they're just like running OpenClaw with a credit card attached to it.
And yes, those are going to be your early adopters on the curve. But in order to get to that, that big meaty section of users, of people using a system, a modern system engineering tool, we need to build that trust in people.
It's also possible the laggards might not exist by the time the early adopters are done.
They become irrelevant,
they're just like, if they can ship so much faster.
Yeah, then you don't need the laggards anymore.
Laggards, it's like, oh, okay.
So who's gonna be right? I guess is the final question.
For the time show. Thank you, Kieran.
Thank you, I appreciate it.
Thank you, guys.